Hello guys, welcome to Brittany and Joss. This is Joss and today I'm going to be doing problem 257. If the resultant force acting on the bracket is required to be a minimum, determine the magnitudes of F1 and the resultant force. Set theta as 30 degrees. So the first thing we're going to do to solve this is, first of all, when solving these types of problems, we're always going to start with what we're given. So we're given that F2 is 200 newtons in the positive x direction. And we're also given that F3 is 260 newtons in the positive x direction and in the negative y direction. So what we want to find for this is F1, given that the resultant force is at a minimum. So the way we're going to start this is we always want to break down our components into our different x and y axes. So since we have three forces, we're going to be doing this 3 times. So we're going to start with our F1 force, which I'm going to write out over here. So we have our F1x and our F1y. So that basically means we want to know how much of F1 goes in the x direction and how much of it goes in the y direction. So we're given here that this is 30 degrees, and I want to go based off the x-axis and not the y-axis. So we're going to be using this angle here instead, which we know is 60 degrees, since this is a 90-degree angle and this is 30. So 90 minus 30 is just going to be 60. And we don't know the value for F1, so we're just going to write that F1 is cosine of 60, and that is our x component for f of 1. So for our f of y, same thing, we don't know the F1 component, so we're just going to write F1, and we're going to write F1 sine of 60, because that is what's going to give us this. So we have F1, so let's break down the components for F2. So as we can see here that all of the second force is in the x direction, so we can just write 200 for that one, and we don't have any of it in the y direction, so this one is going to be 0. So that one's nice and easy. And then for our third one down here, this one goes in the positive x direction. So we have 260. And here we're given a triangle. So we're not going to use sine and cosine, but rather we're going to use our ratios. So we can see here that the x direction has this little 5. So I'm going to do 5 over the hypotenuse of this triangle, which in this case is 13. And that's going to give us the ratio of how much is going in this direction. And then same thing with my y, 260. And then this 12 is going in the y direction, so we're going to write 12 over 13. And that's going to give us our ratio for how much is in the y direction. I have this, I want to add up all of my x components together. So these are all of my x components. We're going to take the x of F1, of F2, and F3, and we're going to use it to find the x of the resultant. And the way that we can do that is we're just going to add this up. So cosine of 60 is 0.5. So we're going to write 0.5 F1, since we still don't know what that value is, plus the 200 plus the 260, 5 over 13. And then we're going to do the same thing for our y coordinates. So it's this one, and this one. So the sine of 60 is equal to about 0.866. So we're going to write 0.866 f1 and then plus 0 because we don't have anything in the y direction for f2. And then this one here, but there's one thing that I forgot to include is that this value is actually negative because this one goes in the negative y direction. Try to pay very close attention to those directions because it does matter a lot whether these are positive or negative. So we have 260, 12 over 13, and those are our x and y components for the resultant. Alright, so now our next step is to find the resultant force using our components. So f of r can be found with this equation right here. So f of r equals f of r of x squared plus fr of y squared. So we're just going to plug in our two values into this equation. So we have f of r equals 0.5 f1, and then 200 plus 260, 5 over 13 is just 300. Squared plus this one right here, 0.866 f1 plus, and then this negative 260, 12 over 13 is equal to negative 240 squared. So that's our whole equation for that one. Equation right here can be simplified to this with a little bit of algebra. I'll skip the headache of all that algebra, but we might be asking, where do we go from here? We want to find the f1, but we have this other variable right here of fr, and we have two unknowns, and we only have one equation. So where would we go from here? So the thing that's going to help us out is actually in the question itself. It says that if the resultant force acting on the bracket is required a minimum. So that word minimum is going to let us know that we need to use the derivative of this equation. So you might ask, why would we need to use the derivative? So the derivative itself is an indicator of change. So it's how fast or how slow something is changing. So given that, you might be asking, why do we need to use the derivative to help us solve this equation? What does the derivative have to do with anything? So at its core, the derivative is an equation that basically shows us the rate of change. So it's going to show us how much an equation is increasing, how much it is decreasing, and if we set that derivative equal to 0, that can help us find our critical points, aka our minimum and our maximum. So this has everything to do with our problem because we want to find the minimum. So let's take the derivative of this. So if you don't remember how to take the derivative, here is a little tutorial. So we have x to the power of n. What we're going to do first is we're going to multiply n, we're going to bring it to the front, and then we're going to subtract 1 from here. So for example, if I had x squared, I would multiply this 2 here and subtract by 1. So the derivative of x squared is 2x. And just one other example for clarity. If I have 3x squared, I would multiply this down, so 6x, and then subtract this, so it would just be 1. So the derivative of 3x squared is 6x. And if I've had x to the third, multiply by 3, and subtract 1. So this would be the derivative of x to the third. So given that, we can easily find the derivative of this equation. So the derivative is going to be, we have 2 here in the exponent, so we're going to multiply that down to get 2 FR and then minus 1, so it's just the power of 1, so we can leave that. And then we're taking the derivative of this part, so I'm going to write dfr over df1. And then same thing for this one. We can multiply this 2 down, so 2f1 minus 1 is 1, so 1 right here. And then this one is just going to be 115. And then the derivative of any constant is going to be 0. So we can leave that blank. So this is our derivative equation right here. And from here, to find our critical points, aka our minimum, we're just going to set this derivative, so this part right here, this needs to be set to 0. So we have 0 equals 2f1 minus 115.69. So with some simple algebra, we have 2f1 equals 115.69. Divide that by 2, and we get that f1 is equal to 57.846 newtons. So now that we have our F1, we can plug back in our F1 to get our resultant force. So our resultant force equation was F1 squared minus 115.69 F1 plus 147.6. So when we substitute this value in for F1, that's going to give us a total resultant force of 380 newtons. Alright guys, I hope that tutorial was useful, that you got something out of it, that you learned something. Thank you so much for watching, and please subscribe. Thank you.